I'm happy to be back here at Stanford and to see both Professors Bielefeld and Harrison in the audience, as my talk is, in a sense, inspired by them both. My interest in the Buddhist culture of vision is indebted to Professor Harrison's pioneering work on the texts and practices of Buddhist visualization, and my interest in the place of India in the Japanese Buddhist imagination reveals the influence of my teacher, Professor Bielefeld, who always encouraged his students to think about the complicated relationship between Indian and Japanese Buddhism. My talk is also indebted to the work of Masahiko Okada, who was a graduate student here at the same time that John was referring to, who I first met when we were grad students here. So what I'll be talking about is the centrality of Indian cosmology in the Japanese Buddhist visual culture. The Indian view of the universe was fundamental to Japanese Buddhism since at least the 8th century, and it was first challenged by the cartography and cosmology of the Jesuits in the 16th century. If there's a way of bringing down the lights in the front, maybe we'll get a better view of the images. And it was defended by Japanese Buddhists long after the Christians had left. So I'll be following the cosmological disputes between European and Buddhist views of the universe far into the 19th century to trace the tenacity and implications of Buddhist visual culture. And by visual culture, I mean, of course, not only the culture of images, but of visuality itself, the theory and practice of vision and the relationship between vision and knowledge. For in the Buddhist tradition, a tradition in which vision serves as the root metaphor for knowledge, the relationship between seeing and knowing, what one might call the epistemology of vision, is always central. So my story begins when European Christians first landed on Japan's shores, bringing with them a radically different picture of the world, and ends with Japanese Buddhists producing images of the universe that had never been imagined. This contest of cosmographies was waged through visual discourse and was, in the end, a dispute over vision. It was not a struggle between East and West, or between pre-modern and modern, or between religion and science. Such simple dichotomies are more than false. They obscure what was common to all participants: the practice of image making and the claims to represent the invisible. Geographic and astronomical knowledge not only provided the conditions of possibility for European travel to Japan, it was also integral to the Jesuit strategy of conversion. Francis Xavier wrote that missionaries, quote, should know something of the globe because the Japanese very much like to know about the movement of the heavens, the eclipse of the sun, the waxing and waning of the moon, as well as the origin of rain, snow, hail, thunder, lightning, comets, and other natural phenomena. The explanation of these things is very useful in winning over the people, end quote. He further noted that the Japanese, quote, do not know that the earth was round. Neither did they know the path of the sun through the sky. They would ask about these things and other such as comets, thundercracks, rain, snow, and other similar things, until they would state that they were quite content and satisfied. They regarded us as learned men, which helped us greatly in convincing them to believe our word, end quote. The Japanese, however, already had a complex cosmology, one that posited Mount Sumeru, or Shumisen in Japanese, at the center of the universe and of our world, known as Jambudvipa, or Nansenbushu, or Embudai in Japanese, to the south. It was a cosmology that the Jesuits knew well and was in fact described by Xavier's contemporary, João Rodrigues, as follows, and this is Rodrigues. In the middle of the universe, Shakyamuni placed a mountain having the shape of an extremely high pyramid, which is called Sumeru. Along the foot of this mountain, there exists 4 lands, one located to the south, one to the north, still another to the east, and finally one to the west. There are 33 heavens divided into 3 stages above this mountain, and the sun, moon, and stars revolve around it. The shape of this mountain is like an hourglass, narrow in the middle and wide at the top and bottom, end quote. The Jesuit preoccupation with cosmology is apparent in the principal textbook of the mission in Japan, the Compendium Catholica Veritas, compiled by the Spanish Jesuit Pedro Gomez in 1593 and translated into Japanese in 1595. Its first section, entitled De Spherae, presents a theory of a spherical Earth and also explains in words and diagrams, quote, the nature of the heavenly bodies, the motion, number, and order of the heavens, solar and lunar eclipses, and the magnitude of the stars and sky, end quote. Jesuit cosmology continued to circulate in Japan even after the missionaries were expelled and their texts proscribed. Material from De Spherae reappeared, for example, stripped of all Christian content, in the mid-17th century outline of terrestrial and celestial globes. Ptolemaic cosmology was also the subject of the 4-volume Heaven and Earth with Commentaries, a treatise introduced by Jesuits, translated by the apostate missionary Cristão Ferreira, and edited with commentaries by the Confucian scholar Mukai Gensho. The influence of both texts, however, remained limited as they circulated only in manuscript and were never commercially printed. In China, however, Matteo Ricci and his fellow Jesuits and their students had assembled a compendia of theological and scientific texts, which included 2 works on astronomical theory, 5 works on instrumental techniques, and a translation of the first 6 chapters of Euclid's Elements. Such books were, of course, banned in Japan, but if Ricci's astronomical writings were proscribed, his world maps were widely known and contained within them the visual explanations of Ptolemaic cosmology. You can see them in the 4 corners of this map. Printed images, then, more than printed texts, were the media by which Christian cosmology circulated in Japan. Ricci produced 11 world maps between the years 1584 and 1608, in addition to a number of terrestrial globes. The third of these maps, issued in 1602, entitled The Complete Map of Myriad Countries, is annotated throughout in Chinese, includes illustrations and explanations of astronomical phenomena in its 4 corners, as visual testimony to, quote, and this is from Ricci's preface, the supreme power of the Lord who rules over heaven and earth, end quote. Ricci's maps included an extensive preface that describes the world in the context of the classical Chinese model of a spherical heavens and a square earth. He writes, quote, the land and sea are round in shape and together form a globe, which is situated in the celestial sphere like the yolk of an egg suspended in its white. It has been said that the earth is fang, that is, square, but this refers to it being fixed and immobile, not to a square shape. But while Ricci was willing to accommodate traditional Chinese understandings of the earth and the heavens, his attitude towards Buddhist models was less generous. He argued that, quote, the folly of the Buddhists is evident in their claim that the Middle Kingdom is in southern Jambudvipa, and their calculations of the altitude of Mount Sumeru are false, end quote. Now, Ricci's map reached Japan soon after its publication and was in use at the Jesuit Academy in Kyoto by at least 1605. Whereas copies of the large 6-panel map enjoyed only limited circulation, small and simplified versions of Ricci's maps appeared in Chinese and later Japanese printed books and had a far greater influence. This simplified copy of a Ricci map was included in Wang Qi's Sansai Duhui of 1609, which also quoted extensively and without acknowledgement from Ricci's preface, including Ricci's criticism of Buddhist theories of Jambudvipa and Mount Sumeru. As the Jesuit author is nowhere acknowledged, his condemnation of Buddhist geography is removed from the realm of Christian polemic and assumes the voice of academic authority. A century later, the Japanese author Terajima Ryoan would include the very same simplified print of the Ricci map in his Wakan Sansai Zue and conclude that, quote, "The Buddhist claim that there are 30,000 worlds is the foolish talk of those who have not carefully investigated matters," end quote. Even if Ricci's books were banned in Japan, his map of the world, his description of the universe, and his critique of Buddhist cosmology reached an untold number of Japanese in what was perhaps the most widely read encyclopedia of the Edo period. Buddhist cosmology came under attack not only from Jesuits, but also from Japanese intellectuals who followed Chinese and later European images of the universe. In 1689, Iguchi Tsunenori published his popular 6-volume Astronomy Illustrated and Explained. On facing pages, he contrasted a traditional image of Mount Sumeru with Matteo Ricci's diagram of a 9-sphere universe to assert the supremacy of Western astronomy over Buddhist cosmology. Iguchi ridiculed the Buddhist explanation of eclipses as the struggle between heavenly deities, but his more fundamental critique was directed at the Buddhist epistemology of vision. Iguchi wrote, quote, "The Buddhists say that they can see the form of Mount Sumeru with the power of the heavenly eye. Astronomers, however, have only the power of the human eye and therefore must rely on theory. Yet the astronomers' explanation of the solar and lunar eclipses are correct, and those of the Buddhists are not," end quote. Now, the power of the heavenly eye, Tengensu, by which, according to Iguchi, Buddhists claim to see Mount Sumeru, is a Buddhological term of art. It refers to the power of infinite vision, a form of sight unobstructed by any obstacle, an ability to see far and near, past and future, inside and outside. It's one of the 6 supernormal powers attained by those who have reached an advanced level of Buddhist meditation, powers that Professor Bielefeld has published on and may even possess. The heavenly eye is one of the 5 modes of vision, or 5 eyes. I can see Fumiko smirking. I don't think so. The heavenly eye is one of the 5 modes of vision, or 5 eyes, within the traditional Mahayana classification of discriminatory knowledge. Thus, by the end of the 17th century, the Buddhist epistemology of vision was already part of the astronomical debate. Buddhists asserted that the power of the heavenly eye confirmed a universe invisible to the human eye. They advanced their claims by reformulating an ancient Indian cosmology into contemporary astronomical treatises that used explanatory diagrams to present the empirical reality of a Buddhist universe. Their arguments and those of their opponents were overwhelmingly graphic. Disputations about the shape of the world and the structure of the universe were made with images. That which could not be seen had to be shown. Throughout the 18th century, Japanese Buddhists reasserted and reformulated their cosmological claims through image production. In 1699, Imai Shiro published an illustrated explanation in Japanese of the solar and lunar orbits, which represented the Buddhist theory of solar and lunar movement with diagrams. 1 year later, the monk Yuhan published a nearly identical treatise entitled Illustrations of Solar and Lunar Movement as Explained in the Dhatu chapter of the Abhidharma Kosha. Similar diagrams explaining the orbits of the sun and moon around Mount Sumeru were published in 1707 by the Kegon monk Hotan in his commentary on the Abhidharmakosha, a 14-volume commentary. Other Buddhists, however, sought to reconcile the cosmology of Sumeru with the possibility of a global Earth. In 1707, Mori Shoken published a 10-volume Defense of Buddhism as a response to Kamazawa Banzan's claim that, quote, the explanations of the ancient saints and sages are no longer believed, and people say that Buddhist cosmology and calendrical calculations are incorrect, end quote. The text includes an image of a spherical Earth with Mount Sumeru at its apex, an illustration that seems to have inspired the Shingonditsu monk Sokaku to construct a Buddhist terrestrial globe of papier-mâché topped with a similarly shaped Mount Sumeru in rock crystal. Two other metal rings of different diameters encircle the globe horizontally and can be adjusted to indicate the sun's orbit between the summer and winter solstice. In 1710, the Kegon monk Hotan, the same guy who wrote that commentary on the Abhidharmakosha, produced the first woodblock printed Japanese Buddhist world map. This is, by the way, David Rumsey's copy, which soon will be in the Stanford collection, entitled Handy Map of the Myriad Countries of Jambudvipa, or more literally, a map of the myriad countries of Jambudvipa held like a fruit in the hand. Hotan uses a religious vocabulary to denote not only a Buddhist vision of the world, but also the very quality of Buddhist vision itself. The phrase fruit in the hand, shoka, is a Buddhist expression for that which is easily seen and comprehended, and signals Hotan's deployment of the traditional Buddhist equation of vision and knowledge. As the map's preface explains, the wisdom eye of the sage is far more powerful than the human eye and sees the boundless 10,000-fold world just like a fruit held in the hand. The preface continues, there are innumerable realms as countless as the leaves of mustard grass beneath the four heavens. Our realm of Jambudvipa is like a single grain within a great storehouse of millet. The ordinary person can see no more of the world than someone inside a cave, peering through a tiny hole. Human vision is as limited as that of the horned owl who can catch a flea at night but cannot see a hill at midday. The vision of an ordinary person is as far from the vision of the wisdom eye as that of a blind person is from the sighted. He can say nothing of the worlds as numerous as atoms. He is like a frog in a well discussing the vast oceans. Hotan's polemic is therefore as much about epistemology as it is about representation. His argument that the view of the world from the perspective of Buddhist vision is qualitatively different from that of human vision relies on the classical Buddhist equation of vision and knowledge. Hotan's wisdom eye refers to the power of vision to discern the true nature of all things. It is, like the heavenly eye, one of the 5 modes of vision within the Buddhist classification of knowledge. In deploying this Buddhist vocabulary of vision in a cartographic context, Hotan is addressing both a mode of perception and the world perceived. To this Buddhist technical vocabulary, Hotan adds allusions to pre-Buddhist Chinese thought, citing at least 2 allegories from the Zhuangzi to illustrate the limitations of conventional perception. It's thus clear that from both his title and preface, Hotan is promoting a particular Buddhist view of the world, as well as a particular Buddhist view of knowledge. Hotan claims not only that his map unifies all geographic knowledge, but also that it allows this knowledge to be held in the hands and apprehended with the eye, grasped both conceptually and physically through the act of vision. More than the visual display of quantitative information, the map offers a new way of seeing, at once total, unencumbered, and commanding. Hotan explains further in his preface, I have integrated all the moat-like countries of Jambudvipa and reduced the scale so it can be held in one's hands. I have thus entitled this publication A Handy Map of the Myriad Countries. With this map, one can take the entire world in a single glance. One can visit distant places without ever traveling beyond one's garden gate. One can point out the various countries of the world just as easily as pointing out the stars in a night sky. With the clarity of stars against the night sky, cartography for Hotan has the power to articulate and perpetuate the significance of Buddhism in a changing world. For Hotan, Buddhist cartography is necessary not only for the accurate and complete understanding of the Dharma, but for the very survival of the Buddhist tradition in contemporary culture. If Japanese Buddhists are to compete successfully in the marketplace of ideas, Hotan argues their geographic knowledge must be equal to or greater than that of their intellectual competition. The religious value of cartography is as significant to Hotan as it is to Matteo Ricci, and much for the same reasons. At the end of his preface, he writes, quote, if Buddhist scholars do not examine this map when they consult the sutras, let this be a word of warning to all of you, their investigations will be incomplete. Confucian scholars have debated geography and discussed distances for generations. If Buddhists do not also pursue cartographic studies, our knowledge will be as insignificant as that of a frog in a well. We must seek as much understanding of distant lands as we do our own, and even more so of Mount Sumeru at the center of the universe and the vast trichiliocosm itself, just as Sudana sought the flower realm and the vast world of Indra's net. End quote. So after noting the scholarly and polemical advantage of a Buddhist cartography, Hotan ends his preface with a gesture towards the larger cosmic vision of the Buddhist tradition. He invokes the example of the pilgrim Sudana, whose journey toward enlightenment is the subject of the Gandavyuha, the final section of the Avatamsaka, or Kegon Sutra, the central scripture of Hotan's school. Sudana's quest for insight was achieved only at the end of his pilgrimage with a visionary experience, an optical spectacle that laid before his eyes the entire structure of the Buddhist universe. In the words of the sutra, Sudana, quote, stripped of all delusion, became clairvoyant without distortion, and with the unobstructed eye of liberation saw all objects without hindrance. He saw a billion world universes in which he saw 100 million sets of the 4 continents, with 100 million Jambudvipas and 100 million heavens of contentment, end quote. Hotan's defense of the Buddhist worldview was echoed by other monks throughout the 18th century. In 1756, the Pure Land monk Mono published another defense of Buddhist cosmology entitled Discourse on the Theory of the 9 Mountains and the 8 Seas. Mono underscored the importance of visual argument by announcing his intention to, quote, use pictorial explanations to attack the falsehood of Western astronomy, end quote. With copious diagrams and illustrations, he explained the movement of the sun and the moon, the mechanism of lunar and solar eclipses, and the process of seasonal change. Mono argued, quote, the world is flat and round and contains within it vast seas like water in a basin, end quote. In 1790, more than 30 years after its publication, the eminent nativist scholar Motori Norinaga denounced Mono's work and asserted that, quote, the theory of the Mount Sumeru universe is fundamentally false, end quote. Now, when Copernican astronomy was popularized in the early 19th century, for example, in the books and prints of Shibakokan, Giryo Doshin responded in 1806 with a text entitled Brief Japanese Discourse on Shakyamuni's Astronomical Teachings, in which he charged that, quote, the Copernican explanation of earthquakes is derived from the Catholic faith and should therefore be treated with suspicion, end quote. In the same year, the monk Mitsuan Shakusoen reiterated the claims of Buddhist vision and inverted Iguchi's earlier critique, writing that, quote, the explanation of Buddhist texts rely on the heavenly eye. Astronomers cannot see by such means and have only the laws of computation, end quote. The figure at the center of the Buddhist cosmography in early 19th century Japan was the Tendai monk Fumon Ensu, who Masahiko wrote his dissertation on. In Ensu's 5-volume Astronomy of Buddhist Countries of 1810, Ensu includes 2 double-paged topographic illustrations of Mount Sumeru. Ensu's volume also includes a remarkable map of Jambudvipa. At the top of the continent is the Jambud tree, from which the continent derives its name, and beneath it, horizontal rows of 7 forests and 7 rivers divide the upper 2/3 of the continent. Only the lower third of the map represents the world of human habitation, a triangular landmass cut off from the rest of the continent. Its northeast corner is labeled Asia. Its northwest corner is labeled Europe, and Africa is inscribed in the southwest. In the center, Ensu has located the legendary Mount Kunlun, a mythic mountain of the Chinese religion tradition that was often conflated with Mount Sumeru. Can I see on this? Here we have Africa over here. Hard to see on the small screen. Kunlun is here. Europe is over here. As Ensu explains, quote, the 3 continents of Asia, Europe, and Africa that appear on the maps that Westerners have brought to Japan are what is called Jambudvipa. The 3 continents were originally one land. Its north, east, and west sides are nearly the same. The south side is narrow and comes to a point. In 1821, a student of Ensu, the Pure Land monk Zonto, produced a large format print entitled An Expanded Image of the World that compiled the encyclopedic detail of Ensu's cosmology in a single explanatory image. Zonto's print illustrates and annotates the main details of the Mount Sumeru universe: the multiple strata of heavens above the cosmic mountain, the levels and dwellings of the mountain itself, the sun and moon on either side, the surrounding mountains and seas, the 4 great continents in each of the cardinal directions, the supporting layers of golden earth, water, and air, and the 8 great hells beneath. The hourglass-shaped cosmic mountain occupies the center of a radiating series of mountains, ranges, and seas. The 4 great continents lie in the outermost ocean, with our land of Jambudvipa clearly foregrounded. Does this? Yeah. Closely following Ensu's map of Jambudvipa, Zonto included the Jambud tree with its triangular leaves at the top of the continent, the 7 rows of forests and rivers and Mount Kunlun, as well as the 3 lines marking the path of the sun throughout the year, according to Ensu's theory of solar movement. In an inscription below this image, Zonto compares the canonical cosmology of Buddhist scripture with the astronomy of European sources. And I quote, according to the Kegon Sutra, the form of the universe is infinite, inexhaustible, and indescribable. Nevertheless, a form of the universe has often been described in both Hinayana and Mahayana texts. This illustration of Mount Sumeru distinguishes the three realms of desire, form and formlessness, and the 25 stages of existence. Today, those who purport to be learned and debate cosmology are unaware of the fact that the entire human realm is but one small part of the realm of desire. Those who refer to the world as myriad lands, Bankoku, which is the term that's in most European-style Japanese world maps of the time, know nothing of the 1,000 worlds of the past and the future. Although they may think they know all that there is to know, their knowledge is no more comprehensive than that of a frog in a well. Zonto continues, ever since I was a child, I have had profound questions about the structure of the universe and its past and future, and these questions have only increased as I have grown to adulthood. One day, following the advice of a teacher, I read the Datu chapter of the Abhidharmakosha and learned that the shape and size of the universe and of the three realms. I have therefore produced this image so that others will not be troubled with similar questions and doubts. In recent years, a book entitled Astronomy of Buddhist Countries, that is Ensu's work, has been published, and in order to clarify the foundations of calendrical science, he has produced a detailed analysis of astronomical matters and, on the basis of domestic and foreign texts, has corrected the errors of Western scholars. Those who study astronomy should read this book, and the design and intention of my print is in complete accordance with it. Encompassing the various heavens and mountains where the deities reside, the world of humans and the distant worlds far away, this illustration makes small things large and large things small, such that they can all be understood and accepted in a single glance. End quote. Citing Vasubandhu's Abhidharmakosha as his source text and Ensu's Astronomy of Buddhist Country as his hermeneutic lens, Zonto offers an image of the classical Buddhist universe for the modern viewer. Like Ensu and Hotan before him, Zonto's cosmology combines scriptural pedagogy with contemporary critique. Reaching back to the vocabulary and tropes that Hotan had deployed over a century earlier, Zonto belittles the blinkered vision of those satisfied with the Richian paradigm, the Bankoku, as nothing more than the myopic conceit of Zhuangzi's frog in a well. Zonto's most significant similarity with Hotan, however, is the promise of a new modality of visual knowledge. Zonto's claim that his, quote, illustration makes small things large and large things small, such that they can all be seen, understood, and accepted in a single glance, end quote. Like Hotan's claim to, quote, have integrated all of the moat-like countries of Jambudvipa and reduced the scale so one can take in the entire world in a single glance, end quote, offers the panopticism of Buddhist insight through the visual medium of the commercial print. A few years later, Zonto produced an even more detailed map of Jambudvipa, characterized by an even greater amalgamation of Buddhist cosmology and Western cartography. The upper register is filled with the traditional representation of Jambudvipa, quite similar to the upper section of both Ensu's illustration and the detail of Jambudvipa in Zonto's earlier print. At the very top of the print is the outermost mountain range and seas surrounding Sumeru, and beneath it the Jambud tree, and alternating rows of forest and rivers. In the lower section of Jambudvipa, however, where Ensu had depicted a single landmass distinguished only by toponyms, Zonto supplies a finely detailed European-style map of the Eastern Hemisphere, with the continents of Asia, Africa, Europe, and Australia carefully defined and named. What might appear to be the Pacific coastline of North America, protruding from the map's eastern margins, is instead labeled Avara Kamara, the Sanskrit name for the island east of Jambudvipa, according to classical Buddhist geography. And Australia is labeled Kamara, the island that Buddhist sources locate to the west of Jambudvipa. A similar map of Jambudvipa, produced by the monk Egon in 1845, illustrates a further articulation of this worldview. Egon's print is clearly based on Zonto's and similarly attempts to unite the classical Buddhist cosmology with a contemporary Western cartography. Yet Egon has reunited the continents of Asia, Europe, and Africa into the familiar inverted triangular form of the Buddhist world, as if to illustrate Ensu's claim that the, quote, 3 continents of Asia, Europe, and Africa that appear on the maps of Westerners are what is called Jambudvipa, end quote. Egon has actually added the Americas, including a depiction of California as an island, for all you Californians, but has labeled them North Kamara and South Kamara. And Australia, fused with New Guinea, and this is for you, Paul, New Zealand, has been labeled Ava Kamara. The prints of Zonto and Egon were but one part of a larger discourse, articulated verbally and visually of an explicit reassertion of Buddhist cosmology in the face of European models. The materials they produced, texts, diagrams, maps, and large format hand-colored woodblock printed hanging scrolls, were promotional materials used in public lectures and meant for popular preaching. As the visual arguments became increasingly complex, the pedagogical imagery did too, and was not limited to the printed page. In order to demonstrate how the horizontal orbit of the sun and moon around Mount Sumeru can explain seasonal change and solar and lunar eclipses, Ensu designed a 3-dimensional model of the Buddhist universe. A print of the model, mounted as a hanging scroll, entitled Model of Mount Sumeru Inscribed and Explained, shows a squat cylindrical device set on a decorative wooden base with the hourglass-shaped Mount Sumeru rising from the center. In the outermost sea lie the 4 great continents, and in the skies above, 8 small disks representing the positions of constellations, surrounded by a ring marked with calendrical notation. A system of fixed, elevated circular tracks is colored red, white, and gold, and marked with regular increments and 2 wire rings along which the sun and moon travel as they orbit the cosmic mountain. Positioned vertically against one side of the device is a black wooden pole with a pulley, escapement, and counterweight. Here. A simple clockwork mechanism regulating the measured movement of the sun and moon as they circle Mount Sumeru. Ensu produced another explanatory print entitled Model of Relative Phenomenon Explained to demonstrate the movement of the sun and the moon as they pass over Jambudvipa. The southern world continent, however, is not represented as the single trapezoidal form, as in his earlier representation, but rather as the 3 continents of Asia, Africa, and Europe, each named and printed in separate colors, produced, compressed to approximate the traditional form of Jambudvipa. It is a hybrid geography combining the continents of Buddhist and European cartographic traditions to illustrate Ensu's claim that the 3 continents of Asia, Europe, and Africa that appear in Western maps is what is called Jambudvipa. If the model of Mount Sumeru is meant to demonstrate the structure and movement of the world as seen from the perspective of the heavenly eye, the model of relative phenomena is meant to demonstrate the world from the perspective of ordinary humans. Together, the 2 instruments are intended to explain the discrepancy between these 2 modes of vision. In the final chapter of Ensu's Astronomy of Buddhist Countries, entitled, quote, Knowledge Obtained Through Vision, Genchi, which I'm tempted to translate as Epistemology of Vision, Ensu introduces what he calls the law of knowledge obtained through vision, Genshi no Ho. After presenting the theories of vision and knowledge from various scriptural sources, Ensu explains that whereas Western astronomy sees the universe from the limited perspective of the physical eye, Buddhist cosmology represents the universe from the perspective of the heavenly eye and the five modes of vision, end quote. The earliest extant example of one of Ensu's astronomical devices is dated to 1824. Commissioned by Ensu himself or perhaps by a disciple, this articulated instrument is nearly identical to the model depicted in the painting and print of 1813. Such mechanical models of the Buddhist world were to be refined and reproduced by Ensu's disciple, the Rinzai, the Tenryuji monk, Kanchu, who had them fabricated by Tanaka Hisashige, the pioneering engineer of automata, clockworks, steam engines, and telegraphy, and founder of what would later be known as the Toshiba Corporation. The image on the left is Ensu's model, and the one on the right is Kanchu's later model. He also made improvements to Ensu's model of the world as seen from the phenomenal perspective. Tanaka produced at least 3 different versions from Kanchu's designs. Precision instruments made of wood, metal, crystal, lacquer, mother of pearl, and clockworks. Unlike the relatively simple model of 1824, animated by pendulum, counterweight, and escapement, which merely demonstrated the movement of the sun and the moon during a 24-hour period, Tanaka's intricate machines shared the complex technologies of his famous chronometers. They marked the movement of the sun and the moon, the date and time, the 24 divisions of the solar year, the passage of the 4 seasons, and the location of the 28 celestial mansions. Kanchu also produced an image and working model of his refinements of his teacher's model of relative phenomena illustrated and explained, and had this new model as well fabricated by Tanaka. In such paired images and instruments, Ensu and Kanchu sought to produce a visual and material exegesis of Buddhist cosmology. In the process, however, they faced a fundamental problem of depicting and explaining a discrepancy between the apparent and the true form of the world. A certain aporia, or perhaps a crisis of representation, exists between their models of the Mount Sumeru universe in its relative and absolute forms. It is as if the models, like the modes of visuality they represent, must remain apart, a kind of double vision that cannot be brought into focus. An attempt to resolve this problem is suggested by the work of the true Pure Land monk Sada Kaiseki, who designed his own model of the Buddhist universe and commissioned Tanaka to fabricate it. Although Sada's device was created to render visible the workings of the Buddhist universe, the very name of Sada's mechanical universe underscores the epistemological gap implicit in the Buddhist theory of vision. It is entitled A Device to Represent the Equivalency of the Apparent and the Real. It was designed to explain the perceptual difference between how the cosmos appears to the eyes of ordinary humans, what Sada terms apparent phenomena. All you Buddhologists are quite familiar with these terms. And its actual form, what he calls true phenomena. According to Sada, the movement of the sun and moon and astral bodies appear as they do to the human eye because of the optical distortion produced by the air in the hemisphere that covers Jambudvipa. This is represented by the semi-spherical cages over the 4 flat continents in his model. Sada terms this misperceived realm, quote, heaven as apparent phenomena, unquote. Sada argues that even though the solar, lunar, and astral bodies do not appear to the human eye to orbit Mount Sumeru, as it is stated in Buddhist texts, they in fact do. He calls this true movement, invisible to the human eye, quote, heaven as real phenomena, unquote. The model is thus designed as a mechanism of visual hermeneutics to explain and understand the difference between the universe as seen by the human eye and the universe as seen by the enlightened eye. In August 1878, the year his device was produced, Sada gave a public lecture entitled A Discourse on Infinite Vision, in which he stated, quote, that Mount Sumeru is situated so high above the earth, several hundreds of thousands of miles, that no human being, however clear his organs of sight, can even conceive the manner of its existence, end quote. It can only be seen by the heavenly eye, which, quote, perceives things that no human eye or intellect could grasp in their present unenlightened state, even though they should use a telescope 1,000,000 times more powerful than any yet invented, end quote. Like Hotan and Ensu before him, Sada understood the differences between Buddhist and Western views of the world in terms of the classical Buddhist theories of vision. Quote, Mount Sumeru cannot be apprehended from the perspective of the physical eye of ordinary humans, end quote, explained Sada. He writes, the true phenomena of the Mount Sumeru universe cannot be perceived with the physical eye, but only with the heavenly eye. This refers not to the eyeball, but rather to spiritual perception, end quote. According to Sada, quote, the vision of the heavenly eye is unobstructed by any barriers. Even microscopes and telescopes cannot compare to its power of vision. The Buddha Shakyamuni acquired it only through ascetic practice. It is the ability to see all, from the heavens of Mount Sumeru above to the hells below, as clearly as an object held in the hand, end quote. Sada's advocacy of Buddhist over Western vision and worldview shares not only the arguments but also the vocabulary of his predecessors. His description of the Buddha's optical command of the entire world, seen as clearly as an object held in the hand, was a standard phrase in Buddhist literature since at least Kumarajiva's translation of the Vimalakirti Sutra. The expression appears in the preface to Hotan's Buddhist World Map and in its title as well. It appears in the title of another text by Sada, Mirror of Mount Sumeru in a Single Glance. Sada's text, also known as Dispelling Doubts About the Heavenly Eye, distinguishes between the normal perception of ordinary humans and the supernatural perception enjoyed by Buddhas and advanced meditators, using the same classical taxonomy of vision outlined by Ensu in the final chapter of his Astronomy of Buddhist Countries. So by the late 19th century, and we're winding up here, don't worry. By the late 19th century, classical Buddhist theories of vision had joined the modern discourse on optics and mechanics and the technologies of human perception. For the previous 200 years, Japanese Buddhist representations of the earth and the universe had to contend with foreign technologies and modes of representation, longitudes and latitudes, Ptolemaic and Mercator projections, terrestrial and celestial globes, orreries and planispheres. Shokoku Dojin was another monk, and don't worry, the last guy I'll talk about, who saw Western astronomy as, quote, the greatest threat to the laws of the state and the teachings of the Buddha, end quote, and also recognized the need to engage and appropriate its scientific discourse. Dojin's new thesis on the defense of Buddhism of 1865 is a 3-volume treatise that critiques the astronomical theories of the contemporary West and presents the cosmological teachings of Buddhist India. Whereas Dojin's critique of Western astronomy and the presentation of Indian cosmology in the 2nd and 3rd volume have much in common with other 19th century Buddhist tracts, the contents of the 1st volume are rather unusual. Instead of the scholastic arguments and scriptural citations of earlier defenses of Buddhist cosmology, Dojin opens with what looks like a primer on modern optics. He explains, through the use of diagrams, the nature of optical phenomena in order to argue that the distortions produced by the refraction of light reveal the limitations and flaws of human vision. Quote, what the Westerners call the study of natural laws are matters of optical perception, of space, objects, size, angles, and straightness. But these are all but small matters of vision within the vastness of the Mount Sumeru universe, end quote. Dojin shares Ensu and Sada's distinction between apparent phenomena visible to the human eye, to which Western astronomy attends, and true phenomena visible only to the Buddha's divine vision. Yet Dojin goes one step further. He uses, quote, what Westerners call the study of natural laws, end quote, to prove the very artifice of optical phenomena. Through a series of diagrams, he attempts to show how the small matters of human vision are flawed, limited, and ultimately unreal. Turning the empirical facts of optical perception against themselves, Dojin mobilizes the vast visual vocabulary of Western science for the purposes of its own undoing. 20 illustrations representing the basic principles of the refraction of light and the retinal reception of images follow. The reader is shown, for example, how objects viewed through a lens appear inverted beyond its focal point. How objects viewed through beveled glass will produce a kaleidoscopic effect. Don't worry, I didn't understand what this was until I went to a physics professor and he explained it to me. I never took physics. How objects viewed underwater will appear displaced and magnified. And how changes in atmospheric perception produce a mirage effect. The optical axioms of Newton, Descartes, and Snell are commandeered by Dojin to demonstrate the instability of human observation and the weakness of scientific claims that they rely on. It is a treatise on Buddhist cosmology that begins with the scientific proof of optical illusions. Dojin's diagrams of optical phenomena, however, are not of his own design. Rather, they are lifted directly from Benjamin Hobson's Natural Philosophy New Edition, published in Canton in 1855 and in Japan in 1864. A British medical doctor and member of the London Missionary Society, Hobson traveled to China in 1840 and during his 20 years in country founded numerous hospitals and wrote several medical and scientific texts in Chinese. He compiled natural philosophy for his medical students in Guangzhou, and it was widely influential as the earliest Chinese primer on European sciences. Hobson wrote that he intended to, quote, convey some instruction in the elementary branches of physics with special references to natural theology, end quote. One volume of the work, entitled Digest of Astronomy, was described by Hobson as, quote, a treatise on the properties of air, light, heat, and electricity, and the elements of astronomy and natural history, designed as an introduction to these various branches of the natural phenomena, end quote. The copious illustrations drawn by Hobson's colleague, Dr. Walter Dixon, are included in the Japanese edition, and a number of them reappear virtually unchanged in Dojin's treatise on Buddhist cosmology. The technical and visual vocabulary of scientific explanation, the laws of physics, and the empiricism of the experimental method are here turned against themselves. The science of optics is appropriated to explain the disjunction between what the eye perceives and the true structure of the universe. The foundations of the Western worldview are disproved by their own evidence and shown in a language visible to all the veracity of Buddhist vision. The images and instruments of human sight belonging to a different order of vision and knowledge than the perception of the enlightened Buddhist. They can offer only an image of the world provisional at best. Yet the Buddhist discourse on vision, even as represented through a visuality of diagrams and devices, appears ultimately a vanishing act. Although framed as rivals, Japanese Buddhists and European Christians may not have had such disparate visualities after all. Both visual cultures engaged in the relentless production of images in order to represent what cannot be seen. Thank you very much.